Welcome everyone. So, if you're gearing up for a software engineering interview at tech giants, places like Google, Meta, or Amazon, you know the stakes are incredibly high. They don't just want to know if you can write a script, they want to know if you truly understand how the language operates under the hood. In this explainer, we're going to dissect the actual questions asked at these top-tier companies. Okay, let's dive into this.
Here's our level up roadmap for today. We're taking a peeling the onion approach. First up, level 1, core fundamentals. Then level 2, Pythonic paradigms. And finally, level 3, advanced internals.
All right, let's kick things off with level 1, core fundamentals. These are the absolute non-negotiables.
Think of these as the gatekeeper questions. If you stumble here, well, you rarely make it to the advanced rounds. Every Python developer absolutely must master these. Let's start with a classic introductory question that interviewers use to test your foundational knowledge. Is Python interpreted or compiled?
It's actually a bit of a trick question, because the real answer is, well, it's both. Standard CPython first compiles your human-readable source code into a lower-level format called bytecode. Then, the Python virtual machine steps in and interprets that bytecode line by line. And hey, if you want to show off a little extra knowledge, you can mention that alternative implementations, like PyPy, use just-in-time or JIT compilation for even better performance.
And this brilliantly illustrates that you don't just have to take my word for it. By importing Python's built-in dis module, which is short for disassemble, you can literally look under the hood yourself. You pass a simple addition function into dis.dis and watch Python reveal the exact bytecode instructions the virtual machine is executing. It's just a fantastic way to visualize that compilation step.
Moving on, an interviewer will definitely probe your knowledge of Python's key data types. We're talking numeric types like int, float, and complex. Text, represented by strings. Then you've got your sequences, like mutable lists and immutable tuples. And of course, sets for unordered unique items and dictionaries for key value pairs. But listen, the absolute golden rule you must voice here is this. In Python, absolutely everything is an object.
So once you establish those data types, the natural next step for the interviewer is to ask, how does Python actually manage the memory for all of those objects? This is our final core fundamental question before we level up. The succinct answer here is automatic memory management. Python primarily relies on a technique called reference counting. It's basically keeping a tally of how many times an object is referenced in your code. When that count hits 0, boom, the memory is freed. But reference counting alone can't catch objects that reference each other in a loop. So Python also utilizes a cyclic garbage collector to periodically clean up those isolated reference cycles.
Okay, welcome to level 2, Pythonic paradigms. This is all about writing good Python.
Now that we've survived the basics, our focus shifts from simple syntax to architectural patterns and code efficiency. A staple question at this intermediate level is, how do generators work in Python? Interviewers at companies like Spotify and Dropbox absolutely love this topic because it perfectly tests your understanding of memory efficiency when you're handling massive datasets. At their core, generators are functions that use the yield keyword to produce values one at a time, pausing execution between yields. Think of a generator like a lazy factory. Instead of manufacturing a million products and hoarding them in a giant, expensive warehouse, which, by the way, is exactly what a standard list does in your system's memory, this lazy factory only produces exactly one item the moment a customer asks for it.
Now, what's really interesting about this is seeing that lazy evaluation in action with something like a Fibonacci sequence. Instead of pre-calculating millions of numbers, the code only computes values on demand when next is called. This proves that you can iterate through practically infinite sequences without ever blowing up your memory footprint. A real game changer.
Continuing in level 2, you absolutely must be ready to cleanly summarize the 4 pillars of object-oriented programming. First, encapsulation. That's bundling data and methods, often hiding internals using single or double underscores, because let's face it, Python developers love their dunders. Second, inheritance, letting child classes reuse parent code. Third, polymorphism, allowing the same interface to work seamlessly across different types. And finally, abstraction, hiding complex implementation details behind a simple interface. Have these queued up and ready to deliver.
All right, brace yourselves. Level 3, advanced internals. This is the boss level.
Take a deep breath, because these are the deep dive questions that truly separate standard mid-level engineers from senior architects. A highly specific, performance-based question frequently asked at top trading firms and massive tech companies is, what is Python's data model and how do slots help performance?
So, why does this even matter? Well, because using slots correctly can literally save your application 40 to 60% in memory. When you're processing millions of data instances, that is a massive, highly lucrative optimization.
So the crucial point is this. By default, Python uses a dynamic dictionary to store instance attributes. Dictionaries are incredibly flexible, sure, but they are notoriously memory-hungry. By defining slots in your class, you tell Python to completely discard that per-instance dictionary, replacing it with a lean, fixed array of pointers. It dramatically improves attribute access speed and slashes memory consumption.
Moving even deeper into system internals, we arrive at the ultimate senior-level question. What are metaclasses in Python? This is a concept that truly bends the mind if you haven't seen it before.
Let's break this down conceptually. Just as a standard class is the blueprint used to create an instance, a metaclass is the blueprint used to create the class itself. It is quite literally the class of a class. It controls class creation at the absolute deepest level.
Let's move on and see how this builds in a practical application. We can actually use a custom meta class to intercept the creation of a database class. By overriding the call method, the meta class enforces a singleton pattern, meaning it ensures that no matter how many times you try to instantiate the database, it will intercept that request and only ever return one single connection instance.
Okay, let's face our final technical boss question, which is often asked by companies dealing with heavy network traffic, like Cloudflare or Stripe. Explain Python's asynchronous event loop internals. To really understand Asyncio, think of a brilliant, single-threaded chef juggling multiple dishes in a kitchen. The event loop is that chef. It's a single-threaded scheduler that manages coroutines. While waiting for a slow task, say water boiling, or in code terms, an I/O network request, the chef doesn't just stand there doing nothing. No, the chef immediately pivots to chop vegetables for another dish. The event loop seamlessly pulls for I/O completion and schedules waiting coroutines precisely when their data is ready. It handles massive concurrency without the heavy overhead of multiple threads.
Phew, that wraps up the technical heavy lifting. But remember, having the right answers in your head is only half the battle. Presenting these complex ideas with structural clarity, a calm demeanor, and confidence is just as important. Interviewers are evaluating how you communicate your knowledge, not just what you know.
So, my final question to you is, are you ready to face the dragon and level up your engineering career? Take some time to review these fundamental, intermediate, and advanced concepts. Practice explaining them out loud, and walk into that technical interview knowing you have the deepest layers of Python completely decoded. Thanks for joining me on this explainer, and